Welcome to another video in the series about the TI ARM CLAN compiler. This video explains the parts of the code coverage display. My name is George Mock and I'm your guide. This video uses the CCS project that appeared in the previous videos, and so the code coverage information has already been collected and post-processed, and now it's time to look at the display and explain what we're seeing. Since the post-processing is already complete, that means that the index.html file is present in the Analyze folder. And that file, the HTML file, refers to things in this coverage folder. So let's double click on this guy and get a look at it. Okay, so first thing I'm going to talk about is these columns here. First column's file name. Fairly obvious. In a larger application, there's going to be many more than one file here. Okay. Function coverage talks about, of all the functions that appear in the file for that row, how many of those were executed. Again, in this particular toy program, it's unexciting in that there was one function and we executed it, so it's 100%. Line coverage. In this particular toy program, there are 31 lines and 30 of those got executed. Skip a region for the moment. Let's go on to branch coverage. There were 12 branches. Actually, we'll see there were 6 branches and they can be taken one of 2 ways. They happen 11 of the 12 ways and comes those percentage. All right, so those are all fairly straightforward. Region is only slightly more complicated. A region is a concept of, it's a block of code that once you enter it, you're going to execute all of it. Okay, that's really all it is. If you think about an if-else construct, that's got 2 regions in it. What's tricky about a region is that a single line of source can, in some cases, contain more than one region. Think about if you have something like if expression 1 and an expression 2. Well, the expression 2 doesn't get evaluated if it turns out the expression 1 is false. So that's a case where on a single source line you can have multiple regions. So in this particular case, there was only one region that wasn't executed, and so it comes to that percentage. Okay, it's time to look at the code coverage of a file. So we click on the file, and here it is. Let's talk about it column-wise to start with. The first column is the line number, fairly straightforward. The second column is how many times did that line execute. Okay, and then the last column is the source code itself. And we'll be seeing that as we go. Let's talk about, so line 4, it says 91. What's going on here? Well, what it's saying is that the preprocessor symbol name limit got referenced 91 times in the source code. So this one, appearing on line 16, is 51, and if I go down a bit, I can see this one on line 37 was executed 40 times, so 40 plus 51 is 91. So that's where that comes from, okay, and so on and so on. Limit format, that preprocessor symbol appears here. That line was executed 50 times, okay, and so on. Oh yeah, let's talk about the branches. So when you see a pair of numbers like this, what it's saying is line 16, column 17. Pretty unexciting here, but if you've got multiple branches on the same line, multiple conditions on the same line, knowing the column number can give you a relative sense of which one it's referring to. Okay, so it says with regard to this particular condition, it evaluated it to true 50 times and false 1 time, and that makes sense. I mean, it's our for loop condition, all right, and the numbers are all constant in this simple toy program, so we know we're going from 1 to 50 inclusive, so it's going to run exactly 50 times, and then on that 51st time, I++ is going to increment to the value 51, and then it's going to fail the this condition test, and then that's the end of the loop. So that's how you can see why it was true 50 times and false 1 time. Let's try and look at another branch and get a sense of how these work. So this one on line 22, starting on column 13, all right, it was true 16 times and false 34 times. The rest of them, 50 minus 16 is going to give you 34. That's where that comes from. And the test here is if I is divisible by 3, well, in the range of numbers 1 through 50, that happens 16 times. And you can see that down here in the output. Every time you've got a fizz, on the numbers that are divisible by 3, including 15, which is fizz buzz, if you count those up, you're going to come to 18. The way I think about it is, 16. 48 divided by 3 is 16. So, these things are all corresponding one to the other. Okay? And I'm just perusing down a little bit. Anything in red is bad. Okay? I put this particular test in if I mod limit plus 1 exactly because I knew it would always be false. It would never be true. So this got tested 40 times and it was never true, and therefore line 38 never executed, right? Well, I did it on purpose, but precisely so that I could show you what it looks like in the coverage output. So one additional mildly interesting thing I did in the code is I put in this continue statement, and we can see what a continue statement does just by inspecting these execution counts. All right, so we know we got to here 50 times. All right, this conditional, we got to that point 50 times. And we know that we only got to the next one 40 times. So that means 10 times, this 10 right here, the continue must mean that we go back to the top of the loop. That's the only way you can get these execution counts. And in fact, that's what the continue statement does in C. It means in the current execution, in the current iteration of the loop right now, and go back up to the increment step, the I++, the test, and then, if the test passes, continue on to the next iteration of the loop. That's what continue does. And another way you can see this is how it's, I've gotten lost myself. I apologize. Oh, yes. The 50 here, and then, it's 40 for the rest of them. Okay? After the loop ends, which is, this is the closing brace for the loop, the execution counts for everything else is 1, which is not particularly interesting. One other thing I wanted to show you is if we go look at the options that are supplied to the post-processing commands, TIARM profdata, TIARM cov, I want you to know that these options, particularly, show branches count, that sort of thing affects what you see here, okay? And I don't want to go through it in any great detail. I just want you to understand that if you change these, which you're certainly welcome to do, because these commands are both documented in exhaustive detail in the TIARM Clang online documentation, feel free to change these, add, take away, whatever the case may be, and then you will see differences here in this output, and you'll start to see things that maybe you're interested in, or you can filter for different things and all that sort of stuff. And I'm not going to take the time to show you all those variations that are possible. But I don't want you to get the impression that what I've just walked you through is the one single way code coverage is always displayed. That simply isn't the case. It looks this way because of the options that are chosen that are supplied to these two commands, and you're certainly welcome to change them as needed. I want to close out this video by giving you a couple of quick references. The first one is to ti.com/tirmclang, the homepage for the tirmclang compiler. It's where you can download it, access the manual, and other details like that. The second reference is to e2e.ti.com. This is where you can go to ask a question on any TI product, including tirmclang. Should that question be about a compiler or a compiler-related tool, that question will be answered by me. Thank you for watching this video in the series about the tirmclang compiler.